Okay, my friends, shocker du jour. I just took a quick look and I think I know what I'm looking at. This is somebody that was a new fan. Hi Roger, I'm a new fan. Discovered your channel a couple months ago. I absolutely love your work. So can you talk about Mayo Room, which is the biggest cave chamber in the world, located in China. The chamber, discovered by a French expedition called Gabi 89 in 1989, measures 852 meters, which is 2,795 feet in length, this one cavern, and 627 feet in width. Has an area of 154,500 square meters. That's 1,663 square feet, a volume of 10 million cubic meters. Okay, so anyway, I'm sorry about the interruption there, but A1 wanted me to look into this. Now, I don't know if those are the biggest caves in the world by any measure. There's a couple in Russia that are just staggeringly enormous in depth. Now, I don't know about this in volume, maybe bigger, because it's a volume of 10 million cubic meters. That's pretty big. So let's look into it. I think I know what it is right off the bat, the first picture I saw, and I think you will too. Because the Earth is made of gigantic, gigantic, gigantic creatures, and I will show you the biology that indicates exactly what it is. Alright, now I haven't looked at this at all, but I can tell you right now, as soon as I started just scrolling down here and saw this, only this one picture, I can tell what this is. I'm saying it's just what it is. Now, it's a vagina. And oh, come on, Roger. Yes, it is. And that's your urethra right there. And this is the body of the vagina, the contour of the vagina. These are tendons. Just like if you reach between your legs, right up real close to your crotch, you've got these tendons running down the sides. Those are tendons. And this is how the legs would have gone. That is the urethra. And this is the vaginal cavity. You see that? And that right there is one of the legs coming down this way. And transitions from this into the tissue that attaches to the vagina. It's like it's a system. I mean, this is what it is. Body is absolutely fascinating. So that's the first place. Now, I believe they're right here, coming in through the vaginal canal. And they appear to be all different pictures. And we're going to, like I said, I haven't gone through this other than to here. And I said, whoops, I know what this is. Let's go through it together. Okay, my friends, this is basically a female anatomy, discussion. That is the urethra, right up there. That's where a woman pees from. All right, and this comes right down into the vaginal canal right here. This is the linea alba that runs straight up. Now, focus in on this transition. All right, this is like a system on its own, the vaginal canal. Then it comes over here. Now I'm going to focus in over here on that tissue where it transitions from the body into the glue that glues the tendon. The tendon is literally glued. That's glue. I notice, I've seen it, I know it very well. And that glues that tendon, and then there's a bunch of tendons in a row that attach to the body proper, which is surrounding the vagina here. All right, so let's see what else they have to show. Because now we're entering the vaginal canal, and maybe we can see some more, maybe we won't. But I think we should, if they're showing it in this kind of detail, some lighting. All right, there's some serious biology right there. And they are they've been through here. There's, you know, it was all big, huge caverns, but nothing really spectacular to see. This, at least you got some biology, layers of biology. Those are layers of tissue. Now, where they are in the body, they're in the probably the fallopian tubes or somewhere in the female reproductive system. This whole area is. So, and that's the person standing down here at the bottom. So that's a pretty good cavity there. And it goes down through this way. So let's see if we can see anything else. Alright, this is what the whole system looks like. So this is a huge big cavity in here, leading a tube leading to it and another one leading the other way. Looks like to me. Now let's see if we can see anything in a female reproductive system that would look similar to that. Well, I wouldn't say it's exactly like that, but we're coming through the vagina. And now, whether or not they were at the very outside of the vagina, I think they were, because I could see the tendons of the legs. But then they finally came through all these big cavities, these huge things, and there's a fallopian tube on each side. And either they were inside of one of these, or, you know, but you can see there's little entranceways in and out, and a big cavity. Pretty much just what we were seeing in this here. And it's got all kinds of different debris inside of it, which is just crazy looking things. And yes, there is crazy looking things inside of them. You see all these little jobbers, whatever they are. And there's tubes running in and out of them. You see this? That's the fallopian tube. And that's where the egg squirts into and comes into the womb. So we've got a tube here and we got a little tubish thing here. Now let's go back and see if we can find that, and then it's all this in the middle. Okay, this is the structure of the muscles and the tendons and so forth that are in the buttocks. Now, if this was open like this, a female, and you could see the vagina, you would see tendons coming down here, which you do see. And the tendons literally glue into a different type of tissue, and then it gets into the actual vaginal tissue. Let me show you. Okay, here's the whole deal in one shot. This is, as I say, the vagina, and I say that is the urethra right at the top. And this is the tissue that actually is the vaginal canal tissue. And then it transitions into another type of tissue just for a short bit, and then you have the glue. Now, what exactly this is, I'm not sure. It could even be a bony substance. I'm not certain. But it's the surrounding that houses the vaginal tissue. Then this right here, and I'm serious, this is glue. That glue glues these tendon straps into this tissue, and they break flat as a pancake. And you see that? That's literally glue. And I'm going to show you, I have some in my shop, same sort of situation. And that is the tendon. Now, that tendon's heavily eroded. Normally there'd be a lot of, it would be sealed, the surface. All right, but there's been a lot of water erosion in here, so it's torn that up a bit. But normally those are just nice flat little straps, and which I'll show you in mine. And I'll show you the glue, and that's what it is. Now let's take a look at mine. Now these are the tendon straps that are in my, it's a bone with the tendon attached to it. So the bone is up here. The glue is here, and the tendon straps go here, and then the muscle starts out here. The same as it would be with that gigantic vagina. You had the glue, and then you had the straps, and then shortly thereafter the muscle would kick in, and so that you could do all your moving. The strap is just there, the tendon is just there to give you just enough oomph so that it doesn't pull out of your body. A tendon is a transition between the anchor and the part that does the flexing the muscle. You know, as you know, I hope by now you know, I claim that there is absolutely zero that exists that is not biological. And here's cosmic caverns down in Arkansas, and you can see the layers of biology, and all this runoff is all secretions of some kind of organ or something. The bodily fluids that are coming out of here flushed out by moisture. But that is not sedimentation where layer. No, this is a creature's body. Now, as I said, there is nothing that isn't biology, zero. And I'm going to show you even stuff in space. There's nothing that isn't biology. And we just went to Comet Bennu and picked up a sample from it, and they can't live with the fact that it's heart sarcomeres. They went in and they sunk deep inside it when they didn't realize they would, and they grabbed a chunk of muscle. And they've got it. It's sarcomeres. Layers of sarcomeres with layers of phospholipids. They call it the phosphate surprise. They never expected that. There's sarcomeres, phosphate. Sarcomeres, phosphate, which is the phospholipid membranes. None of this can be denied anymore, and it's being denied, and it shouldn't be denied. Let me put it that way. And somebody's going to have to do something about it. I can't. I've been raising my voice as loud as I can and putting myself in some jeopardy, I'm sure, because I'm saying things about things that aren't right, and about people that are making them not right. And I hope somebody will stand up. And if I do get in trouble, I hope somebody will stand up and help me, because to date, I haven't had a whole lot of help. So I'm going to just show you what is out in space, and that we're paying billions and billions of dollars for it to look into, and they can't accept the reality of what they found. Okay, my friends, fun at Mudfossil University. Why does space smell like steak? It says the steak-like smell, often described as resembling charred meat or hot metal, it's likely due to the interaction between space and astronauts' spacesuits. What happens is they go out for a spacewalk, when they come back in, they take their suit off, and they say, it smells like sirloin. Well, it is the metals, basically, or they say it smells like welding rods, burning metal, charred meat, because that's what's in blood. That's exactly what's in blood, is all those metals. And possible causes for the steak-like smell, they have no idea. Well, it's radiation into their spacesuits. It is literally barbecue gases. I'll show you. Okay, this is a Comet 67P. It's got a big long name, Comet Kiriyenko or something like that. I go by 67P, works fine. Now, what is that? And what is this little thing here? Well, and then there's some other structures down there, and then there's some gases given off of here, and we're going to be looking at in a minute. But I'm going to tell you what that is. That is a hip joint, and here is what one looks like anatomically. Right there. Now, ours is cracked off somewhere out in here, further out. They crack in a bunch of different places, but you've got the ball and the socket's gone, and you end up with that hip joint, and there's going to be blood servicing this. Well, can we prove that? Well, I think we can. What would the blood do? It would boil off. Can we see that? Yes, we can. There it is. Now, this is back in 2015, and I reported about this to all of the space agencies, everybody thought I was crazy. Well, that right there is an artery. You see that shooting out in space? Why is it shooting out like somebody shooting out of a leaf blower or something? It's not just dusting off. And why are there all these little ones coming up all over the place like this? And why are some going this way and this way and this way and out? Why aren't they coming out of here? I can tell you exactly why. That is an artery. The sun is coming straight down into that artery where that wet, still wet blood is. And it's cooking it just like if it was on a radiation grill, where all they did was irradiate it to make it burn. They're not really burning. There's not enough oxygen to combust. But if there was, it'd be just a flame coming out of here. Now, what's this? Why? Those are blood vessels. You got a main supply, like as your water main. And then you got all your little faucets all over your house. These are here. And they have to come up here to service all the tissue that was here, which was a hip. Now we can see down inside here and actually see the little tiny blood vessels that are inside here that leak all that blood into everywhere else to service. Every single one of these bits and pieces needs to be touched by blood all the time. Now the thing exploded. I think this was during I believe Mars was hit by Venus, and it just splashed everything into space. These are gigantic, and so are the things on Earth, and you're just going to have to get over that, my friends. You're just going to have to get over that. Now, I showed you the hip. There's the hip. There's the hip. Here's the hip. It's got some tendons. It's got obviously some blood coming up to it, which is not shown, but it does. And what else can we see about this? Here is the actual artery. I showed you what the hip looks like. Here is the actual artery. This is 40 millimeters this wide. This thing is about 4 times that. That's 160 meters. That's almost 500 feet for one artery. And all these little dots down in here, these are what they called the dragon balls. Whoops, yikes. All those little dots are where the blood squirts into the tissue, and then it gets distributed around through those little blood vessels. And here's the size of this thing compared to Raleigh, North Carolina. Here's Raleigh, North Carolina, about to here, this downtown, and here's this, that's 67 feet. That gives you an idea how big these creatures were. And that was a creature. I don't care what anybody says. You can actually, there's no how, you can't miss this. There's not an anatomist on the face of the planet can miss this. Not even a 10-year-old. Look at this. That is that hip socket ball. This right here, all of these little stripes, those are tendons. Exactly what you expect to see. Tendons coming out of that ball. What is this? This, I believe, is muscle. And I'm pretty sure of that, but I'm not 100% sure. But all this here, I believe, is the red blood that coming out of that muscle, which the muscles bleed a lot. Tendons don't bleed much. They just don't have any blood to speak of. But muscles have a lot of blood. And I think that's blood coming out of there right there. And all of this has leaked down as red dust. Because it's being irradiated, it's being cooked by the sun. That's what all these gases are giving off. These are all done. These are all cooked. This is well done. But when you can get down inside that artery, now you got something you can squirt out of there. See, all this stuff has already been cooked off. It's because it's been continuously being irradiated. But once you get down into a spot that's pretty well protected, that's when you get the gases cooking off. And space smells like steak because it is just nothing but biology out in space. I'm sorry, that's just all there is. And that's what it is. And up on Mars, they say this is continually over millions of years, these layers. No, this is a creature that was absolutely enormously gigantic. These are muscle sarcomeres. Look them up. Do some of your own research. These are the muscle sarcomeres are exactly what they just came back with from Bennu. There's nothing but biology. And Bennu is so obvious, it's disgraceful that they don't talk about this. Oh, in years we may be able to figure something out. That's a heart, which is this. And the top breaks right off because there's just a gluey thing that glues these to the valves. autopsy guys they know about. I talked to the autopsy guy. He says, yeah, when we take them apart, they just come apart. They just literally fall apart. The tops come right off. Right where and it leaks in. And I know why, because there's a vein and an artery, and they oppose each other because of the chemistry of them. The vein and artery, when the blood stops moving, it's normally going right back and forth next to each other. When it stops, they oppose each other. It's called iron banding. Fe2O2 and Fe2O3, they push each other apart. And it just separates, and you end up with this, just like Psyche. But it's 100% blood almost. Well, hearts are really just about 100% blood. Even the muscle is just saturated with blood. Look at that muscle. That's about the reddest, bloodiest muscle you can get. This is tendon, which is this right here. And then from here up, it's gone. And this has smelted a little bit and gotten real hot, so it must have got next to the sun or somewhere where it really cooked up enough to scorch the outside. I don't think I know the whole thing, otherwise it would just be one big ball. And that's what happens to some meteorites, the metal ones. They come through space and they turn into just a literal ball of metal. And I can show you one now, but it still has veins and arteries inside the meteorite. You can still see the red blood and the black blood. And I have a meteorite right here. And the way you can tell is it'll attract magnets. You see, but it didn't cook enough to turn into 100% iron. There's a lot of iron in this. It's a strongly magnetic attraction, but not enough to turn it into a ball of metal. And when I put this in a microscope, you see this is a lung. This is a lung. And it has the spur lock on it right there. That right there is the spur lock that locks that lung into that creature's body. In the microscope, you will see it. It is undeniable, just as this one here is undeniable, that spur lock. That little flap coming down there, right from there, that tags it in. And then this comes down, and that point at the end latches into the next body part. And there's two little dots on the end of each one of those where the fluids transfer over. And everywhere they pinch into another body part is one of these spur locks. And then it comes back here, and then it flares out into that real thin fascia that coats the muscle. That's all this is some kind of muscle. So anyway, I've got all the evidence to back up my statements and claims, and I would like to make them and be heard and discuss it. It's crazy to spend billions of dollars, billions. And this is not just the only one. I mean, it just keeps going over and over and over. And, and it's not right to do this. They should know better. Now, I showed you 67P and the gas is coming out of there. They analyzed this. They sent a lander down. It was called the Philae lander. This was done by the European Space Agency, and I think it was 2014. But by 2015, pretty much everything was analyzed and looked into. Now, this is the spectroscopy of what is in the molecular makeup of these particles, and they called it Kenneth Juliet, and this one here is IOM means inorganic materials, inorganic matter, and from this Murchison meteorite. So they're comparing this to that. Whatever this was, I don't know. But they're all going to have different materials in them. So this is totally different, this Murchison one, than landing right there on the blood. They're hydrocarbons. That's all blood. That's all blood. But it has a very similar carbon content on all of them. So, but this Murchison one was boiled off or burnt off or whatever. And it could have been a whole nother different body part. What we were looking at is a bloody hip joint. And this is what is, and the Fe is your iron. They all have basically the same irons. Only these flatline, it looks to me, and this one never flatlines. So This one has been cooked. Basically, in my mind, this one's been cooked or is from a different body part entirely. But it still has the iron, obviously. It still has the carbon, obviously. It doesn't have as much volatile organics. It has the silicon, obviously. It has the carbon, obviously. It has hydrogen in it, obviously. All those things are correct on all of them. But this one here, the Murchison one, is almost like cooked. Whereas this one doesn't have much cooking. It's got a lot of volatile chemistry. And that's why you see all those gases shooting out of there. That's not an accident that they're shooting out of there. And this is the artery. And I showed you the artery. Look at 500 feet across. This is not just dust blowing off. This is the smoke that's in, just very, very thin particles. But atomic vapor is that these little things. They say, oh, no, it's a vacuum. It's not a vacuum. They know it's not a vacuum. Nobody, you want to see something? You want to see how much not a vacuum it is? This was taken with a cell phone. This is how much not a vacuum is space is. All of these are fields. And anytime you have to go through a field, I don't care if there's a particle there or not, you are going to be bumping against a field. That's why light slows down coming to us. This is the moon. This is, I don't know what. This is all kinds of crazy stuff going on here. But this is not only this. If you look out in these galaxy pictures and stuff, it's just saturated with particles. But they say, oh, no, light just keeps on going. No, it doesn't. It slows down. We have no idea where we are. All right, I know I talked about Bennu. They came back with this a year ago, and they still haven't said much about it other than, oh, we're really looking into this. It's a heart. I know I already talked about this, and there's no way you can stand behind what they're saying. These are tubes coming out of here. That's a tube. That's a tube. These are not craters. These are valves. That's the tendon. The rest of it is just blood. You see these red, the black, and you see how red that is? That's blood. You see how black that is? That's the vein blood. The yellow is the in-between. That's a heart. And, not an anatomist in the world can go against this. None have. I've shown this to people. They go, well, yeah, it sure looks like it. Well, it could be. It sure looks like it. Well, that's just crazy. It's yes, I didn't say it isn't crazy. Something's true is true. So we have all of these things to back me up, and they have nothing to back them up. And they just came back with this sample right here, which is, if I can find it, the sarcomeres. Right there. These are the muscle sarcomeres. That is a membrane, sarcomeres laying on top of it, another membrane, sarcomeres on top of that. So it's layer, 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 layer. This is exactly what you expect to find in a heart, which is what they just brought back from Bennu. It's here. Well, they've been here for a year. And here's what the muscle sarcomeres are in a heart attack victim right here on Earth. Right there. Same thing. These are the layers of phosphates, which is what they call it, the phosphate surprise. They're phospholipid layers. And these are the sarcomeres. And that is a muscles from a heart attack victim. That's what the heart attack. But this is what they should look like. And they do on Bennu. The beauty of this is, I expected them to come back with some dust that would be blood. And I had given them all of the chemical signature of the blood. All three different types of blood. The whole blood, the plasma, and the vein blood. I categorized them all quantities and types. I sent this off to all the people involved in here. Of course, I never heard a word. And that's all I expected them to find was these particles. But they came back with it. What happened was they went deep inside. They didn't realize when they shot this thing down, they thought it would just hit the surface, grab it, and pop back up. But it went down quite deep, apparently. And it ended up grabbing a hold of some muscle and pulling the muscle out. I was shocked when I saw that. I just absolutely couldn't believe it. That's sarcomeres. There's no way to get around this. And the chemistry will be identical because they went deep enough that this is going to be fresh, just like muscle tissue and blood. I mean, there's so much evidence to support the things I'm saying that nobody can stand against me. I want this checked out for what it is. We spent billions of dollars to do this. You know, Trump and Musk and all those guys, let's get this thing done right. This is not a vacuum. You think that's a vacuum? You see a vacuum there? I don't see a vacuum. This thing's saturated with particles. Absolutely saturated. And light is a particle itself, as I have shown over and over and over, because we could see it. Well, I don't have the shots of it here, but the light is a particle. And that's my dipole electron flood theory, and this is what the particles look like. They look just like that. That's what light looks like. It's a photon. But we can break them and break these two apart and get these two. Sterile muons and electron showers. Changes everything. And so we got to start from scratch again. I want to talk to somebody about this. This is insanity. 15 years of denial from the people we trusted to look out for our best interests. It's not our best interest. It has nothing to do with our interests. Not that I can find. It's got to change. Got to change. All right, I said there is nothing but biology. I don't care where it is. This was a heart or a lung or it could be a liver, but that is the artery and that's the vein. You see that artery, how red that blood is? You see that? It's not in there for nothing. And you see how perfectly round the vein is? And it's black blood. I mean, this is not a mystery here. And blood, which this, when you see a metal iron meteorite, you know it's either a lung or a heart or a liver. Primarily, those are the three that are going to give you the best blood, the best iron. And this one was one that had a lot of iron and cooked all the way down to where there was no scaffolding left, and all of the blood turned into metals. And the metals crystallized along to whatever kind of metals they were, silver or this or that. You know, all the different metals will find themselves. And this was a meteorite. Now, I have a meteorite here, too. And it's metal, and it's still got blood in it. Just like this still has blood in it. You go right in there, I'll bet you get DNA out of that. Well, let me back up from that statement. When you cook anything, I don't care what it is, at a certain point, the bonds of whatever was in there get rearranged. That's what heat does to molecular bonds. That way things cook and they break down. So that could possibly have no DNA whatsoever left to it. But I'll tell you, this stuff is tenuous. And especially the enzymes. I've tried enzymes, the catalase test. Catalase is in every single piece of biology there is. And what it is it's an enzyme that lives in the membranes primarily. And it attacks excess oxygen. So when I put hydrogen peroxide, which has two oxygens, it's H2O2, not H2O. H2O is water. H2O, a single O. H2O2 means you got an extra oxygen. You don't want that. So these catalase molecules will come out and attack the hell out of that, and it'll foam up into bubbles. And I have seen it happen in my meteorites. And I have a whole batch of meteorites here. And I am going to test, I got a couple of them that, well, I got one, I'm almost 100% sure it's a human. And it came out of space. And it's a fingertip. And it's saturated with blood, and it exploded because of all that wet, saturated blood. And I got some DNA test kits in here, and we're going to see what this is, if it has any human DNA in it. And it may not. It came through space, it exploded, it got hot. But I think if I drill deep enough in, I got a masonry drill, and I drill press, and we're going to go down into it and see if we can get deep enough in there to extract something that's vital. Who knows? But anyway, this is what we're up against. This is reality. This is truth. The whole universe is nothing but biology. And that venue, that annoys the hell out of me. I got to be honest with you. That should be, You know, that's billions of our dollars spent. Billions. And a 10-year-old can tell you what that is. And then when they see the muscle sarcomeres on top of that and the phosphate layers, it's impossible. And the chemistry is going to be there. And I bet they can get DNA out of it. Because when they hit, they said they went deep into it and came out. They didn't realize they were going to go deep in. They thought they were just going to hit it and was going to bounce off. See, here it is right here. Unexpected collection of material. The spacecraft sampling arm unexpectedly penetrated deeper into the surface than they had expected it would, possibly due to the loose blood, rubble-like nature of Bennu's surface. The surface was much softer and less compact, because it was just blood, cells. It was much softer and less compact than the team had expected. It allowed the sampler to collect more material, including subsurface material. They went down and grabbed a bunch of muscle. That's what the sarcomeres are. I was shocked when I saw that. You see this? They just reported this one on Ryugu too. I think the Japanese did that one. They created a small crater. They made a little explosion on Ryugu, and then they collected stuff deep. The depth these spacecraft reached was limited to the surface material, a few centimeters below the surface. No, that's not right. Hold on a second. All right, for some reason they say it didn't go deep into this Ryugu, which was the Japanese sent up a probe between 2014 and 2020, and they collected a sample. It's back here, and they said it's biological, has tissue in it, so they must have contaminated it. That's the only solution they can come up with. They didn't contaminate it. They took it off of some biological body part. It says, in addition to collecting surface samples, the spacecraft conducted a series of impacts on the surface to collect subsurface material. They went down and collected the actual tissue samples. That's why it's freaking them out. They can't accept the result. They actually say, oh, we must have contaminated.